It's a little bit small. Okay. So again, we're graphing it. We're going to state the domain, the range, and the intervals where it's increasing, decreasing, or constant. Do you notice how we have 3 different pieces here? So we're going to do one at a time. We're going to start with that first one. It says my function. Okay, this first part is your function, what you're going to be plugging things into. And the second part here is going to be telling you what your restrictions are on your domain. What values of x do you want to use? So the very first thing we have to pay attention to is our inequality. It says x is less than -1, right? Okay, so we're going to do some work. For my x squared function, I'm going to pick some values based off of that inequality there. With my inequality, if it is just less than or greater than without the little bar under it, what kind of circles do we use? Open. So what I want you to do first is just put yourself a little note, if I can. It won't let me slide over here. For that first point, hold on. Let me go do it on the other side so I have some space. All right, so we're going to do the function x squared first. My first point is going to be open because of my inequality there. It says x is less than -1, not less than or equal to. So I'll put a little note there to let myself know when I go to plot these points that part is going to be an open circle. Okay. We're going to include that first number, that -1 that's in my inequality. I'm going to choose that as my first x. And then I want to choose like 3 extra points. So they need to fall in that range, okay, or in the domain. Anything that's less than -1. So what would the next number less than -1 be? -2, okay. And then maybe -3 and -4. Okay. I'm choosing those based off of that inequality. It says x is less than -1. We have to include that -1. That's my starting point. We've made a note that that circle is going to be open because it's just less than. And now we can figure out what our y values are. So start with that x. If I plug in -1, what is -1 squared? 1, okay. If I plug in -2, what is -2 squared? Whoops, 4. If I plug in -3, that's going to be 9. And then if I plug in -4, that would be 16. So I'm going to plot these points. And again, at that first point, -1, +1, I'm going to use an open circle. So at -1, +1, I'm just going to draw myself an open circle instead of closed one. Then all of my other points will be actual points. And then we're going to connect once we're finished with those. I'm going to graph the point -2, 4. And I'm going to graph the point -3, 9. That 16 is kind of off of our graph, isn't it? Yeah, so I'm not going to worry about that one. It's way too far off my grid. So then what I'm going to do is I'm going to connect these. I'm going to start with that open point, and I'm going to go through my other points. And because it says everything less than -1, that means it's going to continue forever. So I can put an arrow out there. Okay with that first point. That's just the first piece of my graph. We're going to take this piece by piece. So for the next one, my function is just my g of x equals 1. And my values are from -1 to +1. Am I going to be open or closed at -1 or +1 with your inequality? Closed at both of them because it's going to be that little bar under it. So I'm going to write myself a little note to be closed. And I'm going to start with the first number on the left, -1. And I need to include all of my numbers in between -1 and +1. So what would be the next number? 0. And then the last number would be 1. Now at 1, is it also closed or negative closed? Or not closed, sorry. It's closed, okay. with this one, because it gives me a specific set of x's to graph, when I plot these points, I'm not going to put arrows on either end because it's just that section in between those numbers. Does that make a little sense? All right. So let's see. If I plug it in, first of all, is there anything for me to plug in? Is there any exit to plug in? So what is the y value going to be for all of these? Just 1, okay. And I'm going to graph this one in blue. Everybody ready? So at -1, +1, what kind of circle am I going to draw? Closed. Is that going to cover up what I already have? Yeah, and that's okay. So I'm just going to go ahead and close that in. Then I'm going to plot the point 0, 1, and I'm going to plot the point 1, 1. I'm going to connect those dots, and I'm not going to put arrows on either end because it's just from -1 to +1. Everybody okay so far? All right. Now we have our third piece that we want to graph. My function is just x. Let me do this in green. This time my inequality says everything greater than 1. So we're going to start with 1, but would that be an open or closed circle? Open, okay. And I'm just going to pick a few numbers greater than 1, so like 1, 2, 3, and 4. And if I plug 1 in for x, it's just going to be 1, right? If I plug in 2, I get 2. If I plug in 3, I get 3. And if I plug in 4, I get 4. So we're going to plot those points now. This one is going to have an arrow on either end because it is not an interval. It's not in between two numbers. It's just everything greater than 1. So I'm going to do an open circle at 1, 1, but that's already closed, so that really doesn't matter. 2, 2, 3, 3, 4, 4. And then I'm just going to connect, and I'm going to put an arrow on the end because, again, it continues because it's just x is greater than 1. Is everybody okay so far? Okay, so that's the first part. That's the graphing. Now let me erase so I have some room to write everything else. Now we want to look at our graph. We want to determine our domain, our range, increasing, decreasing, and constant. So let's start. I want you to figure out what the domain is. When looking at the domain, first of all, see, do we have any spaces? Is there any open circles or any jump from one piece to the other, or is it kind of consistent now that we've got it all graphed? It's consistent, right? So my domain would be from negative infinity to positive infinity. Yep. See if you can figure out the range. Remember, range goes from bottom to top. Because it's going to continue this way forever. So it's going to actually get that far. What's the first y value this graph touches? 1. Okay, so we're going to do a bracket and 1, and then it goes forever up, so that means it takes it to infinity. Then to determine increasing, decreasing, and constant, we are going to go from left to right. What is the red part doing? Decreasing. So it's going to be decreasing from negative infinity to 1. That's the red part here, decreasing from left to right until we get to that x value of 1. What about the blue part? What is that? Constant, and it's constant between what x values? -1 and +1. And then that last section is doing what? Increasing from 1 to infinity. Yeah. So with these, we just basically start with the first function, use the interval that it gives us for our x values, plug them in, plot or graph that part, and then you move on to the second one. So I want you to try setting up your t-chart for that first function in number 2. Okay, pick your values, decide if it's open or closed. Choose the original value and the inequality and like 2 or 3 more. I usually do 3, sometimes you can't graph them all. First function on number 2 is 1 minus x. The interval for your x values, it says x is less than 0. You have to start with 0 and then pick 2 or 3 more numbers that are less than 0. Make sure you decide if that first point is going to be open or closed based on that inequality. And then once you get those values, go ahead and plot your points on your graph. And then you can just hold tight for just a second. What's the number I should choose first? 0. That's the one in my inequality. And is that going to be open or closed? Open. And then I need to choose 2 to 3 more numbers that fit x is less than 0. What are my next numbers that are going to be less than 0 going to be? -1, -2, and -3. All right, then we're going to plug those in. What is 1 minus 0? 1. What is 1 minus a -1? 1 minus -1 turns to 2. Okay. What about 1 minus -2? What does that turn to? 3. And then 1 minus a -3 turns to 4. Okay. So we're going to plot those points. 0, 1 is open. -1, 2. -2, 3. -3, 4. And when I connect, do I go past that last point? Or is it just in between certain numbers? Look at your inequality. Is it in between 2 numbers or just everything less than 0? Everything less than 0, which means I'm going to go and I'm going to connect and I'm going to continue and put an arrow on the end because it represents all numbers less than 0. Okay, so what? All right, the next one is x is your function, and the interval is between 0 and 2. It is equal to 0, but not equal to 2. So think about that when you're setting it up. Your n values, your 0 and your 2, make sure you choose if they're open or closed, and then include every number between. the inequality. And it's got this little bar under it, it's going to be closed. If it goes under the code. Just happens sometimes we have one open and then another one comes on top of it and closes it, so it just covers up that hole. So if it's just x is either greater than or less than one number, it's going to keep going. Did you see how this one has an and on both sides? That's when it stops in between. Does that make any sense? You always start with one number here, and then you should numbers that fit that number less than 0. So that's why we chose negative 1. No, I don't want to start with 0. I want to start with whatever this number is. Yes. You're choosing all of the numbers, whole numbers. We don't want to deal with fractions and decimals. All of the numbers between 0 and 2. Is it going to be open or closed at 0? Closed. What about at 2? Open. Okay. We got that. Less than or equal to at 0, so that makes it closed there. You've got just the less than at 2, which makes it open. And all of my numbers between 0 and 2 are just 0, 1, and 2, right? And so I just get 0, 1, and 2 here. So we are closed at 0, 0, 1, 1, and then at 2, 2 we are open. Do I go past these points and put arrows? No. Okay, it's in between two values, so I just connect those and leave it alone. Making a little bit of sense, sort of, somewhat? All right, try that third one. The function is -1, and it is for everything that is greater than 2. So again, you're going to start with 2, and then pick 2 to 3 extra numbers that fall in that category that are greater than 2. I don't mean to be laughing at your faces. Once you get that done, what I would like for you to do is go through and kind of choose your domain, your range, and then determine where the graphs are increasing, decreasing, and constant. I'm starting at 2. Is it going to be open or closed at 2? It's open, right? And then maybe 3, 4, and 5. And what would my y values be for all of those? So at 2, -1, I am open. And then 3, 4, 5. And I am continuing on because it's everything that is greater than. my line were actually straight, you could see it better, but kind of okay. All right, work on your domain and your range. This is when you have to be careful, and when you look at your graphs to start looking at your domain and range, you've got to look for any holes, right? Any holes or any jumps in my graphs. Do I have to jump, or is it a consistent flow? Does it go all the way to negative infinity? It does, right? Because that arrow continues that way. And then I'm going to go until I see a hole. Well, we have a hole in the red graph, right? But does that blue one cover that hole? It does. Okay, so I'm consistent up until where do I have a hole at both? What number is that? 2. So it's going to go from negative infinity all the way to 2. And then it picks right back up and it goes from 2 to positive infinity. Okay, so our domain is going to be negative infinity to 2. And then again from 2 to infinity. Your range. What's the first y value I touch? Negative what? Negative 1. And it's just negative 1, right? So if you remember when we did this on Friday, if it was just one number, instead of putting brackets or anything, we're going to put the braces. Again, I'm not going to be too strict on that if you put brackets there. As long as you get negative 1 and you jump it, I'm okay with that. But the proper way to write it is that. Okay, so that covers the negative 1 in green. Do we jump from here to 0? Right, because there's nothing in between. So we jump to 0. And then this one stops here, but this one picks up and keeps going, right? So it's going to be from 0 to infinity. And then we can do our increasing, our decreasing, and our constant. Go ahead and take a minute and do those. What is the red doing? Decreasing from? And then what about the blue? What's the blue doing? Increasing from? And then the green is constant from? There you go. Make a little bit of sense, sort of. Okay, I want you to try number 3 all by yourself from start to finish. Okay, so go from bottom to top. What's the first number your graph touches? What, because there's my graph right there, right? So what's that number? Like the y-axis. So it's negative 1, that's fine, that's just like one number. 13, 4. Like she was taking a jump from negative 1 to 0. Because even though this has a whole graph, these coverage are up. So we're all the way up. All right. The first part, the first interval, the first piece of my graph. The function is negative x. My inequality says x is less than or equal to negative 1. So I've got to start with negative 1 and decide, is that open or closed? Closed. Okay. It's closed because of the less than or equal to sign. And then I need to choose a few numbers that are less than negative 1. What would that be? Negative 2, negative 3, and you can even choose negative 4 if you want to. And then we're going to plug those in. If I have a negative 1, what does that turn? Positive. If I have a negative 2, that is positive 2. If I have a negative 3, that is positive 3. And if I have a negative 4, that is 4. All right, so I'm going to be closed at negative 1, positive 1. Maybe. If I can get my graph to work. Okay, and then negative 2, 2, negative 3, 3, negative 4, 4. When I connect those, do I keep going past that last point? Yes, because it's everything that is less than negative 1. Is everybody okay with that part? The middle one, it says my function is 2, but it gives me a range. I want everything in between negative 1 and positive 1. So I'm going to start with negative 1. Am I going to be open or closed at negative 1? Open. And then my ending number is going to be positive 1. Is it going to be open or closed there? Open. And what's in between negative 1 and positive 1? 0. But when I go to plug those into my function, which is just 2, is there anywhere for me to put an x? So what would all of those y values be? 2. Okay. All right. When I connect these, or when I draw these, negative 1, 2, that's an open circle. 0, 2 is here. 1, 2 is another open circle. Do I go past those points or just in between? Just in between. Okay. Okay, that one that has numbers on either side with an X in the middle. Those are your starting and stopping points, and you include everything in between. And then my last piece of this is X is my function. My inequality says I want to choose numbers that are greater than 1, so I'm going to start with 1. Is it going to be open or closed at 1? Open. And give me a couple of numbers that are greater than 1. 2, 3, and 4. And if I plug those in for X, I just get the same thing, right? Okay. So at the ordered pair 1, 1, I am open. 2, 2, 3, 3, 4, 4. Do I continue on past that last point? Yes. And I put an arrow on the end. So that's what your picture should look like. Now we need to do domain, range, increasing, decreasing, and constant. All right, everybody ready for the domain? Left to right. I'm going to go until I have holes that aren't covered up by other spots. So where do I start? Negative infinity. Okay, I'm chugging along. Now I see my blue one has an open circle here, but does that red spot cover it? So I can keep going until I have another hole here. Does that green one cover it? No, so what is my hole going to be at? Where am I going to stop? At 1. And then I'm going to pick back up and go from 1 to infinity. So my domain is negative infinity to 1. I'm skipping over 1 because I have a hole in both pieces of my graph. And then I go from 1 to positive infinity. Range goes from bottom to top. Where is the first point that my graph touches on my y-axis? 1. And then is it continued forever up? Yes, even though I have holes here, my red and my green are both going to cover that. So we go from 1 to infinity. Is it a bracket or a parenthesis at 1? Bracket, because I'm equal to 1 there. All right, red part. What am I doing? Decreasing from to what? Negative 1. Yep. Okay. What about my blue part? What is that? Constant between negative 1 and 1. And then the green part is increasing from 1 to infinity.